The Nobel Prize in Chemistry 2025 is awarded for the development of a new type of molecular architecture, popularly known as metal, organic frameworks, or MOFs. Metal, organic frameworks are porous, crystalline materials composed of metal ions or clusters linked by organic molecules, forming a three-dimensional network. Unique features of MOFs. MOFs are incredibly versatile materials with enormous internal surface areas. They can be precisely designed to perform specific functions like trapping gases or absorbing pollutants such as carbon monoxide. They can even filter and separate gases efficiently. Because of their tunable structures and stability, MOFs have diverse applications. From gas storage and CO2 capture to catalysis, drug delivery, water purification, and chemical sensing. One of the most fascinating applications is atmospheric water harvesting. Certain specially designed MOFs can absorb water vapor at night and release it as liquid water when exposed to sunlight. Even in extremely dry desert air. This property is revolutionary and could transform water availability in arid regions. Now, let us meet the pioneers behind this groundbreaking innovation. The Nobel Prize in Chemistry 2025 is awarded to Susumu Kitagawa, Richard Robson, and Omar M. Yaghi for their pioneering work on metal, organic frameworks. Richard Robson's contribution. The story of MOFs began with a simple classroom moment. In 1974, Richard Robson, a young chemist at the University of Melbourne, was preparing a lesson using molecular models. While drilling holes in wooden balls to represent atoms, he realized that each atom's geometry could determine the structure of an entire molecule. In the late 1980s, he combined copper ions with a four-armed organic molecule, forming a crystalline porous structure. The first of its kind. Although early MOFs were unstable, Robson had unknowingly laid the foundation for this new class of materials. Susumu Kitagawa's contribution. In Japan, Susumu Kitagawa brought persistence and creativity to the next stage of MOF development. In 1997, he created stable, three-dimensional MOFs using cobalt, nickel, and zinc that could store gases like methane and oxygen. He later discovered that MOFs could be flexible, expanding and contracting like lungs as they absorbed and released gases. This breathing property distinguished MOFs from earlier porous materials like zeolites, which were rigid and brittle. In a paper published in 1997, using cobalt, nickel or zinc ions and a molecule called 4,4-bipyridine, his research group created a special kind of three-dimensional metal, organic frameworks that were intersected by open channels through which gases could be passed. When they dried one of these materials emptying it of water, it was stable and the spaces could even be filled with gases. The material could absorb and release methane, nitrogen, and oxygen, without changing shape. Omar Yaghi's contribution. Around the same time, in the United States, Omar M. Yaghi was designing his own frameworks. Inspired by his fascination with molecular diagrams, he coined the term metal, organic framework in 1995. Understanding carboxylate cluster chemistry, a few years later, his team prepared an interesting metal organic framework, coined as MOF5, with a large cavity. This MOF5 was stable up to 300 degrees centigrade. and just 2 grams of it had a surface area that of a football field. The Nobel Prize in Chemistry 2025 celebrates not only the discovery of these remarkable structures, but also the enduring spirit of curiosity, collaboration, and innovation that continues to shape the future of materials science. Metal, organic frameworks have truly opened a new chapter in chemistry. Bridging the molecular and the material world,